between two successful troughs is 3.5 centimeters, and the wave travels a distance of 31.5 centimeters in 1.5 seconds. Calculate the frequency of the vibrator. We are given the distance between two successive troughs, and that is wavelength. Either the distance between two successive crests or successive trough is your wavelength. Okay, so the wavelength there is 12.5 centimeters. If the wave travels a distance x, which is equal to 31.5 centimeters, then in a time which is 1.5 seconds, we should calculate the frequency. Before we can get frequency, we are given wavelength. There is one more thing we need: velocity. But you remember that velocity is equal to distance over time. And we are given distance already, which is equal to 31.5 centimeters, 1.5 seconds. So let's look at what will be the value of that. 31.5 divided by 1.5, we are going to have 21 centimeters per seconds. Can you see that? That's velocity. But we cannot come and say velocity, the relation between velocity, frequency, wavelengths. It's okay? What are we looking for? Frequency, velocity of our wavelength, which is equal to, velocity is 21 centimeters per seconds, divided by wavelength, 3.5 centimeters, which is equal to, let's divide 21 divided by 3.5, we are going to have 6 centimeters. Can you centimeter? We have per seconds, or 6 hertz per seconds, or 6 hertz, because it's the same unit for frequency, and that's the answer. We are going to study another new topic: propagation of sound waves. Under this topic, the candidate should be able to, number one, determine the need for a material medium in the propagation of sound waves. Number two, the candidate should be able to compare the speed of sound in solids, liquids, and gas or air. At the same time, the candidate should be able to relate the effects of temperature and pressure to the speed of sound in air. Number four, the candidate should be able to solve problems on echo, reverberation, and speed. Then, at the same time, the candidate should be able to compare the disadvantages and advantages of echo. Finally, the candidate should be able to solve problems on echo and reverberation. From here, we are going to quickly consider the following as the summary of this topic. That is reflection of sound. This is when a sound wave strikes a smooth surface. The sound will be thrown back and the sound is heard again. That is, it is called reflection of sound wave, and that one will result into what we call echo. Echo. When a sound wave strikes a smooth surface, the sound will be thrown back and that sound will be heard again. It is called the reflection of sound, also known as echo. Okay, so let's consider the speed of sound wave, which is we are referring to echo, has this formula 2x over t, where x is the distance and t is the time. That's the formula to calculate the speed of sound wave, that is the echo, which is equal to 2x over t. X is the distance and t is the time. What are the uses of echo? Number one, echo can be used on a ship for measuring the depth of the sea. Number two, echo are used in oil and gas exploration. Number three, echo can indicate location of possible mineral or oil-bearing rock. You can use echo to indicate the location of a possible mineral or oil-bearing rock. Right now, we are still going to consider sound wave as an example of longitudinal wave. As we know that sound wave can be propagated in solid, in liquid, and in gas. Then we are going to consider the velocity of longitudinal wave. In solid, we have this formula for the propagation of longitudinal wave in solid. In solid, the velocity is equal to the square root, that is the formula. Let's consider what that capital E is standing for. Capital E is the Young modulus. The small d we are having there is the density of the solid. And that's the formula. If you are told to calculate the velocity of a longitudinal wave in a solid, we have this formula. Velocity of longitudinal wave in a liquid, V is equal to square root of K divided by D, where our K is representing Mach modulus, and our D is also representing density of the liquid. This is density of the liquid. So this is the formula to calculate the velocity of the longitudinal wave in a liquid. So also in gas. In gas, the velocity is equal to, we have the square roots, we have something like a gamma, then we also have P divided by D. This is the formula to calculate the velocity of a longitudinal wave in gas. Okay, let's take what each of the term is standing for. Okay, for P, P is the pressure. For this symbol, looking like a gamma, okay, is the specific heat capacity ratio. Okay, then D is the density of the gas. Density of gas is representing that, and that is the formula to calculate the velocity of a longitudinal wave in a gas. And then as we continue, we are still going to see also the velocity of transverse wave. Let's consider question number 1. We have the following figure or the following diagram on the board. The question number 1 says a 90 centimeter uniform lever has a load of 30 Newton suspended at 15 centimeter from one of its ends. If the fulcrum is at the center of gravity, the force that must be applied at its other end to keep it in horizontal equilibrium is, and that is year 2003, question number 10. We have the diagram here. This is our uniform lever. The total length is 90 centimeter, 0 to 90. And then it is being pivoted at the center. This, we have two loads or two weights that hang on this uniform lever. From this center, from this pivot to this side is 45 centimeter. Automatically, from this center also to the other side should be what? 45. Because 45 and 45 will give us 90 altogether. And we are told that from here to here is 15. Automatically, we are removing 15 from 45 because the whole of this side will be 45. So if we remove 50 from 45, we are going to have 30 centimeter. This is clockwise, this is anti-clockwise. And the principle of moment said clockwise moments should be equal to anti-clockwise moments. For clockwise, we are going to multiply the weight with 45 because we are taking our moments from where we have our weight or the load to the pivot or the full cone. Okay, these points. So it's going to be, for clockwise moment, it's going to be W times 45, which is going to be equal to, for anti-clockwise, it's going to be 30 times 30. And what we are going to have is this.